All right, as we wait for the core folks, I think I'm just going to get started here. All right, so this week we had just a couple of, well, actually just one new PR that came in, but this is kind of an interesting one. This is a change in for the MDS lock to switch to a fair mutex. So the idea behind this is that we want to allow things that are waiting, that have been waiting for a while to get access to that lock earlier, rather than potentially being starved by something else that's very frequently trying to grab it. So potentially this could be really, really good. I noticed this in the MDS when I've been doing some benchmarking for Cephfs, that this kind of thing cropped up a lot. So potentially this could be really interesting. It looks like I think Kifu has primarily been reviewed. I don't know if Patrick has been or not, but not yet. It looks like. But yeah, that's an interesting one to have on the radar. Let's see. For closed PRs, there's only one that closed. Kifu merged this one. This is a PG log change or rollback info trimmed. I don't actually remember too much about this. I know it's been there for a little bit. Yeah, we didn't document this too well in the pull request. Well, in any event, that one got closed. Kifu merged it. I think Sam and Niha maybe had taken a look at it, and Sam thought it was fine. So, yeah, that merged. That's good. For updated PRs this week, we've got RGW tracing work. Casey most recently has done some review on that. I think he had a couple of comments that he wanted addressed. So that's being actively reviewed and worked on. Radic has a buffer list PR that is being reviewed by Kifu, who approved it, but then Ilya also reviewed. I think he had a couple of comments. So that's also being actively worked on. There's kind of a long-standing PR here for a TTL cache implementation for the manager, and that's had a lot of work on it. There's performance graphs and a bunch of ongoing discussion and updates. That also is being actively worked on. I'm not sure what the criteria is for merging that, but it looks good. And then there's an old PR that Igor has had in the works for a long time about optimizing PG removal. That unfortunately failed tests again recently. Kifu had done a review and tried running it through the test suite, and it failed. So that looks like it's going to need more review and work to get it passing tests. Let's see. Beyond that, I've got a refactor and cleanup of memstore. It doesn't really improve performance yet. There is an additional object class that's based on vectors that's included in that. About 2 or 3 years ago, that actually was a pretty significant win versus the buffer list object implementation that we have now. But it looks like, due to a lot of work that Radic has done, the buffer list implementation is now actually pretty much on par, maybe even in some cases a little faster than the vector implementation I did. So this does include that, but the bigger thing is that it's just making it a little easier in memstore to implement different object-based implementations and kind of do a little bit of a better job of protecting locks and other things, private data structures. So there's that. Couple of other PRs that came in recently that didn't pass tests in the no movement section, so we'll need to maybe keep an eye on those, make sure that they're not just stalled out. I don't think there's a whole lot right now to talk about. If Adam and Igor do show up, probably we will want to talk about trimming again at some point in the Blue Star caches, but for now, not necessarily. So, okay, that's PRs. Did I miss anything, guys? All right, well, we are still waiting for the core stand-up folks, it looks like. But I will get started on discussion topics and they can come in and join in when they get here. So the big one that I've got this week is that the internal work group folks at Red Hat went through and did a bunch of work looking at performance of kind of our internal next-gen Red Hat Ceph storage that's based on Pacific. This is kind of like the release candidate for that, versus the old one, which was based on Nautilus. So essentially, we can think of this as basically Nautilus versus Pacific. And things did look really good overall in the final version of their testing, but one thing that did crop up that was concerning is that we saw significantly higher write amplification on the NVMe base DB and wall partition in the OSD. So while performance was actually faster overall, we saw that the SSD drives were being worked much harder than they were previously in Nautilus. And the reason this came up was because they were noticing that the OSD logs were much bigger than they had been previously, and they were like, "Well, this isn't good. This is gonna take up a lot more log space than it did." Well, it turns out that was because there was a whole lot more logging being done for compaction and for write-ahead log flushing than previously. So the end result of this is that this isn't really a good thing. It's going to wear out SSDs faster when used for DB and WAL, and it's also actually significantly slower in some cases if you have enough backend throughput and you're really hammering those SSD or NVMe drives. So, okay, I went through and tried to replicate this in-house on our internal test cluster, and I was able to do so. And this is a machine. These are machines that are actually using NVMe drives, not hard drives. But I basically changed it so that I was looking at the equivalent preferred deferred size that we use in hard drives, and the results are in this spreadsheet. I will paste it into the chat window here. That's right here. What we're seeing is that, well, okay, before what we're seeing, in Blue Star, the way it's supposed to work is that we will have a threshold where below, for object sizes, write sizes, where if a write is below that threshold, let's say it's 64 KB on hard drives, then we'll defer the write. We'll write it to the write-ahead log in RocksDB, but we won't immediately write it out to the block device. Instead, we'll defer it and hope that we can combine writes and do some tricks to make the actual write faster to avoid seeks. You don't need to do this on NVMe drives. So on NVMe, we instead will not defer. We'll just do the write immediately. Previously, that was fine. For large writes, we didn't do this. We did not defer. We just wrote it out immediately, and because it's a large write, the seeks didn't matter as much, and that worked great. Now, for whatever reason that's not immediately apparent, when the Blue Store preferred deferred size is equal to or larger than the blob size in Blue Store, we see a huge amount of deferred I/O traffic going into the write-ahead log and into the memtable buffers. That ultimately leads to this write amplification and actually, in some cases, really poor poor performance. When the preferred deferred size is significantly smaller than the blob size, this doesn't happen. And this happens even when the I/O size is extremely large, say 4 megabyte. This is really different than the way that BlueStore used to work. So right now I'm trying to understand why this is the case. And it does look like we got folks in from Core now. So
sorry, Mark, there was a very interesting discussion happening.
Yeah.
So
I know. I knew it was going to be that way. I was like, oh no, this is going to go like another.
Yeah.
Yeah. So I went through PRs and I just gave an intro to the data that I mentioned briefly yesterday and posted a spreadsheet in the chat. Just very briefly recapping, the gist of it is that previously in BlueStore, if you had a large I/O, a large write come in, you would often not see that, or you'd never see that deferred if you had like a min-alloc size that was significantly smaller, right? So if you look at 64K min-alloc size and you have a 4 megabyte large write coming in, that would not be deferred. That would then immediately be written out and you'd see the benefit of that. What appears to be happening now is that even with a very large write, like a 4 megabyte write coming in, if the BlueStore preferred deferred size is equal to or even kind of near the max blob size, then we see a huge increase in deferred I/O traffic going to the deferred column family in RocksDB, causing lots of I/O hitting the memtables and Red Hat log, causing flushes to happen more quickly, which means that PG log data is not being tombstoned before it's being moved into L0. All of this combined creates a massive storm of write amplification and additional work being done by RocksDB, especially during compaction, but also just the generally flushing from the memtables into level 0. So I'm trying to understand this behavior. Why is this happening? Adam and Igor, you both know this code, I think, better than anyone else does. So I wanted to bring this to you. The data is in the chat window in a spreadsheet, so please feel free to look and comment with your thoughts.
I would like to share one observation that I made some time ago while playing with blob sizes during compression. I was surprised to see that the way we handle, I mean, of course, I might be wrong to some degree, but my observation was as follows. We first, even for a very large write, we first chop the data into blob sizes. To the packets that are blob size actually relevant to the situation we have. It might be different for different cases in the same cluster, but let's assume we have some blob size for a specific write. After we split the data for chunks, we then apply the rule whether apply or not the deferred operation. So I've seen that if I have like 4 megabytes and I had exactly the same deferred write size as a blob size, then I have everything put through deferred column in RocksDB. That's basically all I want to, that I have to say about that issue. And my thinking is that in past we had much smaller deferred write size and we never met the blob size, but then we noticed how useful it is because it's very useful for HDDs especially to when we increase the size, we got more performance. So maybe that's why we never seen that before, and now we we can have that issue. That's all from my side.
Well, a couple of cents from my side. Yeah, Mark, I've seen your email and I'm working on preparing a response at the moment, but it looks like this logic is pretty complicated and well, I would expect that larger I/O produce some deferred operations in case your input blocks are not aligned to blob size. So when you write 128K, I suppose the alignment is still 4K. Is that correct?
It should be.
So in
Unless there's something yeah, go ahead.
Yeah, and in that case, you at least have two chunks, head and tail, which to be put into deferred operation. Yeah, Bootstrap tries to align or tries to perform these deferred operations on unaligned head and tail. I'm still curious if that wasn't the case for before. I need to double check. But well, so I'm still investigating that anyway. Just a couple of ideas to troubleshoot that on your side, if you like. First of all, I suggest to use just a simple radius put, where you can provide an offset and hence produce an unaligned write. And also there are some performance counters which show how many data goes to deferred or not. So it might provide some insight what's happening. So I definitely, so the only thing that I managed to try so far is to check this max block size at 64K versus 256, and indeed I could see that deferred operations, that there are some additional deferred operations in case of smaller max block size. I'm planning to check what happened in earlier versions, and well, we'll respond. But yeah, so just two ideas so far. Try simple put with some offset and try to analyze performance counters.
Sure. I believe in Nautilus our max blob size was 512K, right?
Maybe I need to double check, and I don't know. But you know, I think that before Pacific, this max blob size didn't impact deferred operations. Yeah, at least for in this. So just to introduce one term, so we should distinguish small and big writes, and so given that min alloc size is 4K, everything below this value, every write below this 4K is considered as small, and this had deferred operation support from beginning, and big writes which are longer than 4K, they've got deferred operations for Pacific, if I remember correctly. And it looks like this new functionality might be different. So, and the deferred operations was trying to replicate small write deferred operations before Pacific, which tend to work on 64K. So yeah, it might need some additional investigation, and maybe there are some issues there, indeed. So, well, I'm working on that as well.
Okay. Igor, do you think it could be as easy as just if you have a large write coming in before we break it into different blob sizes, chunks, blob size chunks, we just note that this was a large I/O and we don't defer it?
Well, actually, that new deferred functionality for big writes is an attempt to reproduce the previous deferred writes implementation for small writes. So I realized that when we downgrade the min alloc size, we could have worse handling at spinner drives due to a less amount of deferred operations, and hence so if earlier we had deferred operations for blocks less than 64K as well, and now we should to do that processing. We should do an additional processing to support that, to simulate the same behavior and to get hopefully the same performances for spinners as before. But maybe something is broken on this in this simulation. Maybe it performs more deferred operations than before, but this needs additional investigation.
I might be misunderstanding or misinterpreting Adam's explanation, but it seems like it makes sense that if you're breaking up the write I/O down into different blobs, and then you're deciding whether or not to defer based on the blob size, that then if your preferred defer size is equal to the blob size, and those blobs are typically smaller than or equal to that limit, then that those would end up being deferred, even if it's a large I/O, right?
Right. So the size of the block itself is not the only factor to decide whether we need to apply deferred operations or not. It's also alignment of this block, which is taken into account. So and again, that's an attempt to reproduce the previous behavior for spinners. Even you have this 128 kilobyte block starting at 32K offset. The original spinner behavior was to apply deferred operations. So this head part, which is 32K, to be deferred. Well, it was deferred before, and now we are trying to defer it as well. The same for tail part. With such an alignment, you will get an additional 32K blob at the end, which you need to part to 64K and then apply the deferred mode. This is how it worked before, and that's why and actually it showed better performance for spinners than just writing this long block as is without applying deferred operations.
I don't think I have anything else to really ask about now, other than that, or just say other than that, there's more testing that needs to be done, I think.
Well, one more comment. So at this point, I would rather be interested in the difference between the earlier versions in how it worked in before Pacific and the new one than this. So it's expected that deferred operations on spinner might produce pretty significant load to database. And it did that before. The question is whether it becomes even larger or not. Or maybe we changed like something in RocksDB, some settings on newer version which handles that traffic in a worse way.
So Igor, this actually did come out of a study inside Red Hat that isn't public, that was looking at the old version of Red Hat Ceph storage versus kind of a new prototype version based on Pacific. So this is essentially, you can think of it as Nautilus versus Pacific, really. And this behavior was not seen in Nautilus. In Nautilus, based on the standard min-alloc size and blob size and preferred deferred size at that point, we did not see this. But if I remember correctly, I think that the max blob size was much larger as well. And of course, the code has changed dramatically. So the defaults at that point didn't do this.
Yeah. So first of all, we need to understand if we provide more data to database from BlueStorm compared to the Nautilus or not.
I think that's definitely a yes. When I looked through the logs, I saw specifically that in Nautilus, we had far fewer flushes coming in from the write-ahead log and mem tables into level 0 than we did in Pacific.
Mm-hmm. Okay, but well, then the next step would be rather to simplify the benchmarking, or maybe come to some simple scenarios which show the difference, and then analyze what changed. But I'm taking a look at that.
Sure.
On my plate.
Adam, you've been quiet. What are your thoughts?
Well, my thoughts is that I have to replicate my tests when I was surprised to see that everything goes to deferred writes, and I will do that and come back with report.
Okay. Okay. Does it, based on what you had said earlier, when we first started today, um, does this behavior make sense based on your understanding of the code?
I remember that sometime, I'm not really sure it was Pacific or maybe even earlier, we added a code to also get deferred rights for big rights. There were some cases when we could do that. And since that time, we are able to also do deferred from a big rights in Blue Store. And that, I think, triggered the case that in some specific values of blobs and deferred rights, we just always trigger the condition that we want to defer. But I just analyzed it then, didn't really bother with it because I got it only when I made very atypical sizes for blobs, and basically I ignored the drop of performance because there was not so much in that. And that's it. I mean, my estimation is that if we put everything through deferred, we will have exactly the results that we have: very much database data, frequent comparisons, and very much write amplification. A lot of write amplification.
Yeah. And frankly, the results that this team saw was actually that Pacific was faster. It was actually not worse in performance than Nautilus.
That's actually the question. So you shared the numbers for all flash cluster, as far as I understand, and
Correct.
it could be worse there, but actually all this stuff is intended primarily for spinners, and it's I'm
The
curious
problem
if
though, Igor, the problem though was that the write amplification was so huge on the drive that one, it was actually making the logs significantly bigger than they used to be because of all the compaction and flushing and everything. But then, you imagine that like a 10x or 20x increase in write amplification, even for hard drives, that's a lot of wear on SSDs if you have like 5 or 6 OSDs targeting one SSD as write ahead log and database. And extra CPU too. The CPU usage went up.
okay. So this might be the case when we would face sort of trade-off between space saving performance and these write amplifications to the disk, and there is no perfect answer here. So we might increase one thing, but make another one worse. And
one question for you: what if we just changed the deferred size to 32 KB? In the test that I did for large IOs, the behavior was much better for large IOs when we did that. Do you think that would be bad than in other circumstances?
Well, definitely downsizing the preferred deferred size would provide less traffic to database, but then another question would be how it impacts the performance, and it's unable to. It's hard to tell without real investigation. So when choosing these parameters for Pacific, I was trying to reproduce what we had before with this deferred stuff. But I paid attention mostly to performance. So perhaps we missed something in terms of this purification and things like that. And that's why interesting what's the performance difference in your case for spinners. So you're saying that Pacific is still faster.
It appears to be so.
Good,
Yeah.
That's good, and that's what I tried to achieve.
Yeah. So is from a performance standpoint, I don't think what we have now is actually terrible. It might be if you really overloaded the SSD. I think in their testing they had very fast like Optane drives for the well and DB and has high write endurance and all these things. In that case, this might be ideal. But if someone had a much lower write endurance or slower SSD for their DB and WAL partitions, and they had lots of hard drives for OSDs being used, per SSD, then it might actually be significantly slower because going from a 32K to a 64K preferred deferred size is like a 10x write amp increase.
Right, and so we might come to a decision to have different parameters set for different SSDs.
Maybe. It seems like there's a boundary there, though, right? Like when you have the blob size and the deferred size equivalent, that's when you see this huge increase in write amplification. But my question is, what's the trade-off? Is there a good reason to have those equal, or does it, are there benefits to that, or is it just kind of a downside?
I can't tell at the moment, and I'm afraid there are too many factors here, so to have a simple answer.
Yeah, I understand.
For me, the most difficult part of the answer is that if we use deferred, then Igor, please verify if I'm correct. I think that we might override the same allocation. So if we use deferred writes, we can overwrite objects without fragmenting them. But if we use the typical write, then we need to allocate extra space, thus increasing fragmentation. So that's an additional level why deferred might help preserve high speed operation for clusters.
Well, it could be the case for before that, before Pacific, we had allocation unit less than preferred deferred size. And in that case, we could rewrite same block. And even in that case, I'm not sure we did that. But right now we have a different case when block size, where each deferred operation writes to multiple blocks. And it's hard to, so depending on the disks, depending on the existing block layout, it might be beneficial to rewrite blocks, or if they are sparsed, allocate instead a single long block and write there. So again, there are no looks like there are no single approach here. It might be hard to say which way is beneficial. It depends on what layout is on the disk, and things like that. But I recall no but maybe you are right. It doesn't perform in additional location. Need to double check that. But the key point is that before Pacific, deferred operation was always less than location unit. Now that's not the case, and this complicates things.
Guys, I don't have anything to add on deferred writes and write amplification at that time. I need to make a test to actually continue conversation on that topic.
Yeah, same to me actually.
Okay, that sounds good. I agree. I also want to do more testing on it. So and read through the code a little bit more.
Yeah,
I
but
didn't.
but I would suggest to try simple scenarios actually. Before just single write and check what happens. It's more informative than trying a huge load.
Sure. Mostly this was just to replicate what was seen by the QE team inside Red Hat, because I wanted to verify that in our cluster we saw something that looked like what they were seeing. At this point now, I agree with you. I think it's good to go down and see if we can understand the specific behavior. I did in the chat window post what our defaults were in Nautilus and what they are now in Pacific. We did have a much larger blob size than the preferred deferred size, which may, even by itself, would potentially explain the difference, even without all the code changes. But as you said, Eeyore, it might not even have mattered at that point. One other thing before we wrap up that I wanted to point out in these results that was really interesting, I don't know if it's related or not, is that in these 128K random reads, when the preferred deferred size increased from 0 up to 16K, it doubled this 128K random read performance. I have no idea why. I don't know why the behavior manifested the way it did, but it seemed...
Well, first of all, the question is, are you pre-filling the disk or the store with some data before?
Correct.
And what write pattern is used there?
So, in these tests, the prefill is with 4 megabyte writes to fill the drive, and then it's going through and doing sequential reads in order by IO size, then sequential writes in order by IO size, then random reads in order by IO size from smallest to largest. So prior to the random read test at 128K, there were 4 megabyte writes hitting the disk to fill it. Then there were sequential reads, which shouldn't matter. Then there was 4K, 128K, and 4 megabyte writes hitting the blocks in this RVD test prior to the random reads happening.
Mm, So I presume that you wouldn't see this effect if no random writes happen before the reads. But
Random.
actually it's prior writing which changes the layout of blocks on the disk, which might affect the performance. It's not the reading itself. So reading doesn't depend on preferred deferred size. It should be, yeah. So reading on a new store and reading on the store impacted by the previous random writes would be different. So and then yeah, so this again, this preferred deferred write, preferred deferred size is rather impacted the prior random writes, and hence implicitly affected the reading.
There were no random writes before the reads. Those happened afterwards. It was sequential writes that happened before random reads.
Okay, but again, curious if the reading behavior differs between. So if no smaller writes before the reading or after that.
One curious aspect of this as well, though, is that it did not affect the large reads, only the medium-sized. Small and large were both fine. It was just these 128K ones that were affected.
Yeah, well, this needs additional investigation.
Yeah, exactly. That's what my thought was too. I have no idea why this is, but it's a very curious thing happening.
And this is stable behavior, so tried it multiple times, right?
Exactly. All right. Well, it sounds like we have work to do. So I don't have anything else. Are there any more on this or any other topics people want to bring up before we end for the week? All right. Well, Adam and Igor, both thank you very much for looking at this. I suspect this will be a kind of a hot topic as we try to do our release, and then I'd imagine for Suze as well, this will be good to figure out. So thank you both for looking at it, and I will also continue to look at it next week. So thank you all, and have a wonderful week, everyone.
Yeah, thank you. Bye-bye.
Thank you. So next week we compare notes.
Sounds good.
Thanks, everyone.
All right. Bye, everyone.